Hello and good afternoon. Today we're going to be discussing alternating series, which is Chapter 11, Section 5. And before I jump straight into the problems that were assigned, I'd like to kind of go over what an alternating series is and then the rules that follow an alternating series. So, by definition, an alternating series is a series whose terms are alternately positive and negative. So basically what that means is that an alternating series follows a certain type of pattern. So this pattern can be your first term be positive and your second term negative, and your third term positive and obviously your fourth term negative. But it could also mean that I could have my first term negative, my second term positive, my third term negative, and my fourth term positive. As long as it follows kind of a recursive type pattern, it sticks to the alternating series. So obviously there are rules that make up an alternating series. And that rule is in fact the alternating series test. So I'm just going to abbreviate it. The alternating alternating series test states that if all the terms of an alternating series decrease towards zero in absolute value, then the series converges. So basically what that all means is that can sum up into exactly, I guess you could say, two sub rules to this. I'm going to say sub rules, basically conditions to this. So the first condition is in fact b sub n plus 1 is less than or equal to b sub n. And this is for all n. Fix that real quick. This is for all n. Basically what that means is that b sub n plus b sub n plus 1 is less than, or excuse me, that is of or equal to the previous term. That's all it really means. Now I'm going to go ahead and go to the second condition, which is simple. Limit as n approaches infinity, b sub n equals 0. So b sub n must equal 0 when you're taking the limit as approaches infinity. It must equal 0. These are in fact the two conditions that are going to make an alternating series converge or convergent. So now since we have a little bit of what alternating series is and the conditions that follow the alternating series test, let's go ahead and start doing some problems. I'm going to erase this real quick. Now, the alternating, let's go to the first problem. Now, the first problem basically states it's going to give us a series which is n equals 1 to infinity, and it's going to ask us whether or not this is going to converge or diverge. Converge or diverge. So it's basically asking us whether it converges or diverges. So I'm going to start off by taking the limit of this. So limit is n approaches infinity equals, excuse me, yeah, equals, oh, so let me erase that. So let me write it again. The limit is n approaches infinity of n squared n cubed plus 1. So as I plug in infinity to n, that's going to be infinity over infinity. Oh, well, you know, if you recognize this from our past lessons, this right here is L'Hopital's rule, which means I'm going to do it again. But this time I'm going to take the derivative of it. So as the limit is n approaches infinity of 2n over 3n squared. Well, we'll go ahead and plug in infinity again, and what do you know? We're going to go get infinity over infinity. So L'Hopital's rule is in place again. Take the derivative of this again, so the limit is n approaches infinity of 2 over 6n. Now I'm going to simplify that to be 1 over 3n. And this that I plug in infinity is going to be 0. And because of that is because you have a very, very large denominator to a very small numerator. And as infinity keeps going on larger and larger and larger in the denominator, the whole is going to become smaller, meaning 1 over whatever number you have to infinity is going to get smaller and smaller. So this is going to get to 0. So found our first condition. So let's go to our second condition, which our second condition is going to be b sub n plus 1 is less than or equal to b sub n. So I'm going to write this out one more time. Oop. So basically what I'm going to do here is I'm going to exclude the 1, and because of this, the 1 doesn't really matter when you have n to a very large power, because any number you plug in there, it's going to get very, very large very quickly, and the n is just insufficient. So I'm going to have this as n cubed over, n squared over n cubed. Yeah, so this is going to become, I'm going to subtract it, n to the negative 1, which translates to 1 over n. But now I'm going to bring in my b sub n plus 1 is less than or equal to b sub n, which this right here is our b sub n plus 1. This is going to become 1 over n plus 1, which is less than or equal to our bn, which is this, n squared over n cubed plus 1. So to test this out, I'm going to go ahead and stick in 2. This is going to give me 1/3. And if I do this, it's going to be 4 over 9, which in fact 4/9 is larger than 1/3. So what do you know? This second condition is correct, follows the guidelines. So this here, so by the alternating series test, write this out again, n plus 1 cube x squared over q plus 1. By the alternating series test, this series here converges. So that is how you do the first problem, or how you apply those conditions to the alternating series test. But now the second question is asking us is whether or not we are allowed to use the convergence test, or excuse me, the alternating series test. So I'm going to go ahead and write what it is. It is series equals 1 to infinity, negative 1 squared over n squared. So it took me a little bit to figure out what I can actually do with this problem, but I had to go back to the definition. So the definition of an alternating series, once again, is a series whose terms are alternately positive and negative. So what I did was I just started plugging in the, oh, excuse me, this is 2n. But what I did was I started plugging in for n. So let's go ahead. I started doing, 2 times 1 over 1 squared. This is going to give me 1. Okay, we're allowed to have that as our first term, but now we have to make sure that our second term is going to be negative. So I go ahead and plug in 2. 2 over 2 squared, which is going to give me 1/4. But once again, it's not negative. So because of this, you cannot, it is false, you cannot use the alternating series test here. And what you're actually going to use is in fact p-series test. So let's go ahead, equals 1, and -1, 2n, n squared. This is going to convert to, might as well go ahead and plug in 1. But this is going to go ahead and do 1 squared, which, as we remember, if p is larger than 1, it converges. It converges. So you cannot use alternating series test in this series. You cannot. But yes, that is in fact the alternating series test, and these are some of the things you should keep in mind. That's the definition and the bound, not the bounds, but the conditions to alternating series test. But yes, I thank you guys for watching. I appreciate it. Bye.